Out on the open ocean, a modern commercial vessel operates as a tireless engine of global trade, moving tens of thousands of tons of cargo. Across hemispheres, she can easily generate upwards of $50,000 in charter revenue every day. Yet, no matter how flawlessly she performs on the owner's balance sheet, a non-negotiable milestone dictates she must soon stop trading and return to land. This is her special survey date. Entropy at sea is a measurable physical process. From the exact moment a ship is launched, corrosive saltwater, relentless hydrodynamic stress, and biological colonization actively work to consume her steel. Pausing to address this invisible damage triggers a severe economic penalty. Every day spent off-hire means zero revenue. If a forced delay causes the vessel to miss the strict cancellation window for her next commercial charter, an industry timeframe known as her laycan, the financial impact can spiral into the millions, as replacement cargo is simply awarded to a competitor. The vessel absolutely must stop. The ocean demands its toll, and the authorities monitoring her condition do not negotiate. The ship has reached the end of her current operational life. The highly profitable voyage is over, and the physical reality of the ocean has finally caught up with her. The authority governing a vessel's very right to sail rests with classification societies. These independent technical organizations mandate a rigid 5-year inspection cycle to guarantee ongoing structural seaworthiness. This inspection cycle escalates in severity over time. Annual visual checks give way to rigorous intermediate surveys, where inspectors crawl through dark ballast tanks. At the 5-year mark, the special survey explicitly requires a full physical dry docking to assess the underwater hull and rudder. For high-risk vessel categories, particularly oil tankers and massive bulk carriers, an even stricter framework applies, the Enhanced Survey Program, or ESP. The adoption of this hyper-focused inspection regime was driven by a chain of catastrophic structural failures at sea. The primary catalyst was the loss of the massive British bulk carrier MV. Layered over these class rules is a sprawling statutory framework governed by the International Maritime Organization. Core conventions like SOLAS for life safety and MARPOL for pollution prevention set the uncompromising legal baseline for global shipping. Government inspectors, known as Port State Control, act as the frontline enforcers of these conventions. If a single mandated survey or dry docking is missed, an expired certificate allows these officers to paralyze a multi-million-dollar ship in port instantly. Missing the dry docking window renders the ship instantly uninsurable and ineligible to load cargo. Without valid statutory certificates, the vessel becomes a rogue asset, legally blocked from entering any major commercial port. Long before the ship smells the industrial air of a repair yard, meticulous preparation begins in corporate offices thousands of miles away, orchestrated 12 months in advance by a shore-based technical superintendent. Their primary tool is the repair specification. This exhaustive blueprint synthesizes data from computerized maintenance systems, crew defect reports, and upcoming survey requirements to prevent the repair industry's greatest threat, scope creep. This chart tracks projected dry docking budgets. The flat baseline represents the initial specification. When unplanned emergency work is discovered, the budget spikes exponentially upward. This stacked bar graph reveals the truth. Direct repair costs are dwarfed by massive off-hire revenue lost while sitting empty. To mitigate these crushing off-hire losses, superintendents rely on critical path management, the discipline of identifying the longest sequence of dependent tasks, like steel renewal and paint curing, to compress total time spent in dock. Ship owners also align their trading routes strategically with massive high-volume repair clusters in Asia and the Middle East to minimize costly voyage deviation time. Conversely, specialized European yards thrive by focusing on complex environmental retrofits and strict regulatory timelines, catering to fleets that require advanced engineering over sheer volume. In the ship repair industry, every single hour saved through parallel work streams and geographic alignment translates directly into protecting the owner's margin. Time saved is the foundational business model of ship ownership. When the scheduled date finally arrives, the ship halts commercial operations. She officially enters off-hire status, slows her enormous diesel engines, and is guided by harbor tugs into a flooded graving dock. The heavy steel caisson gates slide shut behind her stern, sealing her from the open ocean. massive dewatering pumps roar to life, evacuating millions of gallons of churning seawater back out into the bay. As the water level steadily drops, the thousands of tons of ship settle with millimeter precision onto a prearranged grid of reinforced concrete keel blocks. The draining process reveals the immediate biological toll. The newly exposed lower hull frequently carries an entire invasive marine ecosystem, thick, stubborn layers of barnacles and tube worms that the ship has unwittingly transported around the globe, which must be immediately cataloged and stripped away. She is now stripped bare and entirely vulnerable. Her trading phase is over, and the violent, necessary process of cutting away the damage is about to begin.